Something came back from the dark, and nobody is talking about it the way they should be. 12 billion miles away, in a region of space no human eye has ever seen, where the sun's light is nothing more than a faint star among billions, a machine the size of a small car, running on power weaker than a refrigerator light bulb, broke its silence. After months of the deepest kind of quiet that exists in the universe, Voyager 2 transmitted something structured, something deliberate, something that made scientists at NASA's Jet Propulsion Laboratory stop what they were doing and stare at their screens. The question is not whether the signal came. It did. The question, the one nobody's answering clearly, is what exactly came back with it. Think about the last time you truly lost contact with someone. The silence is uncomfortable, unsettling, eventually terrifying. Now stretch that silence across 7 months. Now stretch the distance across 12 billion miles. Now imagine that on the other end of that silence is not a person, but a spacecraft launched by human hands in 1977, carrying a golden record of Earth's sounds and greetings, drifting further from home than any object humanity has ever sent into the cosmos. That silence broke, and the signal that ended it was not what engineers expected. It carried structure. It carried patterns. And what those patterns are revealing about the region of space Voyager 2 is now passing through is forcing scientists to quietly revise what they thought. They understood about the boundary between our solar system and the interstellar void beyond it. This is not a story about a malfunction. This is not a story about a spacecraft dying. This is a story about what happens when the last eyes humanity has beyond the solar system open wide and report something they were never supposed to find. To understand why this matters, you have to understand where Voyager 2 actually is. Not in the abstract, feel-good NASA press release sense, in the real, physical, almost incomprehensible sense. Voyager 2 is currently more than 12.8 billion miles from Earth. It is one of only 2 active probes humanity has operating in interstellar space, and every single piece of data it sends back is, by definition, unique. There is no other instrument, no other machine, no other set of sensors anywhere that is measuring what Voyager 2 is measuring right now. When it goes silent, humanity goes partially blind to a region of space we have never directly observed. When it speaks again, the entire scientific community listens, not out of nostalgia, out of necessity. But here's where it gets complicated. Voyager 2 has not been speaking easily in recent years. The probe is dying. Not dramatically, not all at once, but slowly and methodically, instrument by instrument, watt by watt. Voyager 2's plasma science instrument was switched off in late September 2024. Then, Voyager 2's low-energy charged particle instrument followed in March 2025. These were not accidents. These were calculated decisions made by engineers who understands that every instrument drawing power is a day subtracted from the mission's life. The spacecraft now operates with only 3 active instruments: the triaxial fluxgate magnetometer, the cosmic ray subsystem, and the plasma wave subsystem. 3 instruments on a probe with a nuclear power source that generates less electricity than a standard household lamp. And yet, with those 3 instruments, Voyager 2 is still gathering data that no other machine on Earth or in orbit can replicate. Think about what that means. Scientists are making decisions right now about which piece of the universe to stop listening to, because they cannot afford to listen to everything anymore. That is the position humanity is in with its most distant emissary. And against that backdrop of managed decline, against that careful procedural winding down of a half-century mission, Voyager 2 sent back something that disrupted the expected pattern, something that was not in the scheduled telemetry, something structured. And this is where everything changes. In April 2025, NASA's Deep Space Network Station in Canberra, Australia, picked up a short, garbled transmission from Voyager 2 that was not like any signal previously received from the vehicle. The initial reaction from engineers was skepticism. When you have a spacecraft that is almost 50 years old, running on dwindling nuclear power, operating in an environment of intense cosmic radiation, the first explanation for anomalous data is always hardware degradation, a failing transmitter, radiation-induced bit flips in the onboard computer, interference from the deep interstellar medium distorting the signal before it reaches Earth. These are rational, scientifically grounded explanations, and they were the first ones considered. But then the analysis teams kept going, and the signal refused to behave like noise. The data packets that arrived didn't match any known signal pattern from the probe. At first it seemed like a malfunction, but the signal was intentional. It repeated itself. It followed a pattern. Voyager 2 appeared to be functioning, but in a language its own creators no longer immediately understood. Read that again, slowly. The machine was working. The transmission was real. But what was being transmitted followed a structure that took days to decode. Not because the technology failed, because what was being reported was something engineers had to assemble carefully from fragments before they could understand what they were looking at. The Deep Space Network, humanity's most powerful antenna system, spent days processing this data. Commands were sent back to Voyager 2. Some went unanswered. The signal would behave erratically, then suddenly clarify into bursts of readable information, then fragment again. When engineers finally cracked the pattern and translated the packets into readable form, what emerged was data describing a dramatic and acute change in the composition of interstellar particles and radiation intensity in the region of space surrounding the probe. In other words, the environment that Voyager 2 is moving through right now is not what the models predicted it would be. Something has changed out there, something significant enough that the probe's own sensors flagged it as a priority transmission. Now pause here, because what follows requires you to understand something about the science of where Voyager 2 is operating, because without that context, the significance of what was detected becomes invisible. Voyager 2 crossed the heliopause in 2018. The heliopause is the boundary where the solar wind, the constant stream of charged particles flowing outward from our sun, becomes too weak to push back against the pressure of interstellar gas and radiation. Beyond that boundary lies the local interstellar medium, the vast ocean of gas, dust, plasma, and cosmic rays that fills the space between star systems. It is a region we have theorized about, simulated, calculated, and modeled for decades. And until Voyager 2 crossed into it, we had never directly measured it from the inside. So when Voyager 2's remaining instruments begin reporting data that doesn't match the models, the implications run deep. What Voyager 2 reported was something subtle, but in some ways more unsettling than a dramatic discovery. The space around the spacecraft has changed. The transmission itself arrived with an unusual delay and an unexpected distortion pattern, as if something between Voyager 2 and Earth was bending or scattering the radio waves. Interstellar space is not a perfect vacuum, but it does not normally interfere this dramatically with signal propagation. The fact that the signal itself was distorted in its physical journey from Voyager to Earth means that the medium between the probe and us has properties that our previous measurements did not capture. Something in that vast emptiness is denser, more active, more complex than the models suggested. But here's where it gets worse. On July 11th, 2025, NASA's Deep Space Network was presented with a stream of data that ran counter to expectations. Voyager 2, wandering more than 12.5 billion miles from home, appeared to transmit an anomalous energy burst, a compact package replete with irregularities. On initial inspection, it resembled static, perhaps the product of malfunctioning instruments or background noise. But after decoding for several days, mission analysts identified structured data within that static, suggesting a dramatic, acute change in the makeup of interstellar particles and radiation intensity. This was not the first anomalous signal. It was the second. 2 separate transmissions, months apart, both carrying structured patterns embedded within interference, both describing the same basic phenomenon. The interstellar environment around Voyager 2 is behaving differently than it should. The pattern of what is being detected points toward what some researchers are describing as an interstellar scale event. Something is happening in the local interstellar medium in the specific corridor of space that Voyager 2 is moving through. The probe's cosmic ray subsystem is registering variations in high-energy particle density. The plasma wave subsystem is picking up disturbances in the electromagnetic environment. And the magnetometer, the most basic of the 3 remaining instruments, is detecting shifts in the local magnetic field structure that suggest large-scale organizational forces at work in the interstellar medium. Not chaos, structure, not randomness, pattern. What most people are not seeing is the cumulative weight of what this means. These are not isolated instrument glitches. Multiple separate sensors on a single probe operating on independent systems are all registering anomalies in the same location at the same time, pointing in the same direction. In science, when independent measurements converge on a single anomaly, you take notice. The probability of simultaneous, independent instrument failures producing coherent, structured, consistent data is extraordinarily low, which means the most likely explanation is also the most scientifically interesting one. Voyager 2 has moved into a region of interstellar space that is physically different from what surrounds it, and it is reporting that difference with every transmission it can manage. And the probe is managing fewer transmissions than ever before. This is the part of the story that introduces a kind of urgency that goes beyond scientific curiosity. The Voyager project manager at JPL, Suzanne Dodd, has been direct about the stakes. If we don't turn off an instrument on each Voyager now, they would probably have only a few more months of power before we would need to declare end of mission. That statement was made in the context of instrument shutdowns, but its meaning echoes through everything happening right now. Every transmission Voyager 2 sends costs power. Every decoding session the Deep Space Network runs, every command sent back across 12 billion miles of interstellar space, every attempt to extract More information from the probe. All of it is drawing down a budget that has already passed the point of no return. The instrument shutdowns were not a retreat. They were a calculated trade. Sacrifice some sensors to keep the critical ones alive long enough to report whatever Voyager finds as it moves deeper into the unknown. And right now, what it is finding is something the scientific community did not fully anticipate. Recent measurements indicate subtle differences in cosmic ray behavior near Voyager's trajectory, specifically a damping effect. In simple terms, something ahead of Voyager appears to be shielding it from high-energy particles. The leading hypothesis posits a massive magnetic anomaly, possibly a remnant of a long-dead star or a local interstellar cloud. But the symmetry of the dampening field is highly unusual. A dampening field with unusual symmetry, think about what those words mean when placed next to each other in a scientific context. Natural phenomena in space, shock waves, stellar remnants, interstellar cloud boundaries, tend to produce gradients. They get more intense as you approach them and less intense as you move away. They have irregular edges. They are shaped by the chaotic dynamics of cosmic gas and radiation over billions of years. A symmetrical dampening field is the kind of structure that requires an organizing principle. And in the interstellar medium, far from any star, far from any planetary system, the question of what provides that organizing principle is not one that has a comfortable, conventional answer. The real story is that what Voyager 2 is entering may represent the edge of something. Not a technological structure, not an alien intelligence, but something potentially just as profound from a purely scientific standpoint. A region of interstellar space shaped by forces and dynamics we do not yet have adequate models to describe. Our understanding of the local interstellar medium is built almost entirely on remote observation. We have detected it with telescopes, measured it with instruments in Earth orbit, extrapolated its properties from the data Voyager 1 and Voyager 2 have been sending since they crossed the heliopause. But remote observation is always a shadow of the real thing. It is the map, not the territory. And the territory is telling Voyager 2 something the map did not show. Consider the timeline of discovery here, because it reveals something important about how dramatically our understanding has shifted in a very short period. In 2018, when Voyager 2 crossed the heliopause and officially entered interstellar space, the scientific consensus was that the probe would encounter a relatively uniform interstellar medium. Cooler, denser, more magnetically organized than the heliosphere, but predictable. The models were robust. The data from Voyager 1, which had crossed the heliopause 5 years earlier in 2012, seemed to confirm the basic framework. And for the first several years of Voyager 2's interstellar journey, the data it sent back was broadly consistent with expectations. Then something changed. The plasma densities began shifting. The cosmic ray intensities started fluctuating in ways the models did not predict. The magnetic field measurements began registering structures that the simulations of the interstellar medium had not produced. And Voyager 2's transmissions started carrying the signatures of an environment in transition, not stable, not uniform, but actively changing as the probe moves through it. The structured signals that came back after months of near silence are the latest and most dramatic expression of this transition. Something out there is different. Something out there is making Voyager 2 work harder to report what it finds, and the probe is running out of time to tell us everything it knows. Voyager 2 continues to send data back on cosmic rays, magnetic fields, and plasma waves, giving humanity its sole direct measurement of interstellar space. Sole direct measurement. There is no backup. There is no redundancy. When Voyager 2 finally exhausts its power, and that day is coming, its RTG, radioisotope thermoelectric generator, losing roughly 4 watts of output per year, humanity will lose its only in situ sensor in interstellar space. We will go back to remote observation, back to the map, back to theories and simulations and extrapolations. And whatever region Voyager 2 is currently passing through, whatever anomaly it is detecting, will go unmonitored. From the inside, we will be left with the data it managed to send back and the questions that data raises without fully answering. According to informed sources within the planetary science community, the structured signal transmissions from Voyager 2 have triggered a reassessment of several established models of the interstellar medium's local structure. The data does not break physics. It does not require exotic explanations, but it does require revision of assumptions that have been baked into the standard models for years. The interstellar medium near Voyager 2's current trajectory appears to be characterized by higher magnetic complexity, greater cosmic ray density variation, and larger scale organized field structures than the models predicted for this region. None of this is impossible. All of it is scientifically significant, and none of it would be known without those structured signals coming back across 12 billion miles of space. But here is the layer of this story that carries the most weight when you sit with it long enough. Voyager 2 was not designed for this. When the probe was launched in 1977, the mission profile covered the outer planets: Jupiter, Saturn, Uranus, Neptune. 4 planetary systems in one extraordinary grand tour made possible by a rare alignment of the outer planets that occurs once every 175 years. The probe was built for a 5-year mission. 5 years. Now, almost 50 years after their launch date, both Voyager, spacecraft have reached interstellar space, a remarkable achievement. The engineers who built Voyager 2 are in their 80s and 90s now. Some of them are gone. The technology inside the probe is older than the personal computer, older than the internet, older than GPS. It was built with technology that modern smartphones make look primitive. And yet, it is still functioning, still transmitting, still somehow discovering things. There is something almost unbearably poignant about that. But do not let the emotion distract you from the scientific significance. Because the fact that this aging, power-depleted, instrument-stripped probe is still generating scientifically disruptive data is itself a testament to the quality of what was built. The magnetometer is still functioning. The cosmic ray subsystem is still functioning. The plasma wave subsystem is still picking up the electromagnetic murmur of interstellar space. And together, those 3 instruments are painting a picture of a region of space that nobody knew looked the way it looks. The plasma variations are getting stronger. Transmissions are growing harder to decode. Whatever Voyager 2 has found, it's not fading. It's getting more intense. That progression, stronger variations, harder decoding, increasing intensity, is not what you would expect if Voyager 2 was moving into a stable region of interstellar medium. It is what you would expect if Voyager 2 was approaching the edge of something, or moving through the interior of a structure that becomes more organized and more energetically active as you go deeper into it. The probe is not leaving the anomaly behind. It is going further into it. And with each transmission, with each structured signal that makes it back across 12 billion miles of distorting, complex interstellar space, the picture of what that structure looks like becomes slightly more defined. The international scientific response to the data from these transmissions has been notably restrained in public, and notably intense behind closed doors. Within 24 hours of signal confirmation, NASA scientists coordinated with SETI and other international agencies. Not because anyone was seriously suggesting an extraterrestrial intelligence, but because the signal analysis required input from teams with expertise in pattern recognition across multiple frequency domains. When you have structured patterns and data from the edge of the solar system, you bring in every analytical tool available. And Google's AI Studio was among those tools. In April 2025, NASA's Deep Space Network recorded a very peculiar and garbled signal, and Google AI Studio was brought in, using advanced deep learning models and state-of-the-art signal analysis to assist in pattern extraction. This is new territory in space science, artificial intelligence being deployed to decode transmissions from the edge of human reach. The combination of 50-year-old hardware in interstellar space and cutting-edge machine learning on Earth working together to understand what the universe is showing us. That is the state of the mission. Right now, primitive and sophisticated simultaneously. What those AI-assisted analyses are revealing, when layered on top of the traditional instrument data, is a picture of the local interstellar medium that is more structured, more complex, and more dynamic than the pre-Voyager model suggested. The cosmic ray damping effect, the magnetic field asymmetries, the plasma density variations, the anomalous signal distortion during transmission, taken individually, each of these could be explained away as instrument noise or statistical fluctuation. Taken together, they form a coherent pattern pointing toward a physical structure in interstellar space that our models did not anticipate in this location. The real question now is not whether the structure exists. The data says it does. The real question is how large it is, what maintains it, and what it means for our broader understanding of the galactic neighborhood that our solar system inhabits. And here's the part where the stakes become genuinely civilizational in scope. Our solar system does not sit still in the galaxy. It is moving, orbiting the galactic center at roughly 514,000 miles per hour, completing one full revolution roughly every 225 million years. As it moves, it passes through different regions of the local interstellar medium, some denser, some thinner, some more magnetically complex than others. The composition and structure of the interstellar medium around the solar system has direct consequences for the intensity of cosmic radiation reaching the inner solar system, for the dynamics of the heliosphere that partially shields Earth from that radiation, and potentially for long-term climate patterns on Earth. Understanding the local interstellar medium is not purely academic. It is, over geological timescales, relevant to the conditions for life on this planet. What Voyager 2 is detecting now, the anomalous structures, the unexpected particle density variations, the magnetic field complexity, may be a sample of what the solar system will encounter as it continues its journey through the galaxy. We are not positioned to measure that from Earth. We are not positioned to measure it from orbit. We can only measure it from where Voyager 2 is inside the interstellar medium, moving through it in real time, sending back reports from the frontier. The silence of those 7 months was not empty. Something was accumulating in the interstellar medium around Voyager 2 during that period, building toward the structured transmissions that broke through. And now the probe is sending back signals that are becoming harder to decode as the environment around it intensifies. The probe is detecting an organized structure or influence outside the heliosphere. Something is there, interacting with the transmission rather than simply existing passively in the background. Something in interstellar space is not merely being detected by Voyager 2. It is affecting the signals Voyager 2 sends. It is leaving its fingerprints on the transmission itself. This is not chaos. This is structure. And structure in science is always a clue. The probe that was supposed to last 5 years has now lasted nearly 50. It crossed into interstellar space. It survived a communications blackout in 2023 when a misaligned antenna cut it off from Earth for weeks. It eventually resumed contact after NASA sent an extraordinary interstellar shout across more than 12 billion miles of space, and the probe responded. It survived further instrument shutdowns in 2024 and 2025. And now, past all reasonable expectations of longevity, running on instruments it should have lost years ago, Voyager 2 is still discovering, still transmitting, still telling us things about the universe that we did not know. But the power reserves are finite. Each instrument shutdown is treated as potentially permanent. The decisions being made right now at JPL about which sensors to preserve and which to sacrifice are among the most consequential choices in the history of space exploration, precisely because there is no replacement. No mission currently planned or funded will put another probe in interstellar space within the next several decades. The next window for a grand tour-style trajectory, the planetary alignment that made Voyager's route possible, does not open again for over a century. When Voyager 2 goes silent for the final time, that silence will be permanent. So the structured signals coming back now, in this narrow window of remaining power, carry an urgency that is hard to overstate. Every transmission is potentially the last one. Every pattern extracted from the data is potentially the final piece of a puzzle that may never be completed. The scientific community knows this. The engineers at JPL know this. And the probe, in its own mechanical, non-sentient way, is operating at the absolute edge of its physical capability to keep sending information home. What comes next depends on questions that currently have no clean answers. Will the 3 remaining instruments hold? Will the power reserves last long enough to transmit from the deepest regions of the anomalous? Structure Voyager 2 is now moving through. Will the deep space network, with its imperfect coverage and competing demands from dozens of active missions, be available to capture every transmission? And will the structured patterns in the data from this region of interstellar space eventually resolve into something that can be described by existing physics? Or will they require genuinely new theoretical frameworks to explain? The honest answer from anyone working on this mission is, we do not know yet. The journey of Voyager 2 is a reminder that exploration is rarely comforting. It is mostly filled with uncertainty, surprise, and moments that unsettle even the experts. The newest transmissions fit that pattern exactly, a faint signal from the dark, carrying with it a message that challenges assumptions and hints at mysteries that exist beyond the reach of our sun, beyond the reach of our models, beyond anything we have sent a machine into before. 12 billion miles away, a probe built half a century ago, with technology that today's engineering students study as history is passing through something that science did not fully anticipate. It is sending back structured signals from a region that distorts even its own transmissions on the way home. Its power is fading, its instruments are going dark one by one, and with the few sensors it has left, it is still finding things, still reporting, still somehow discovering. The silence lasted 7 months. The signal that broke it carried structure, and that structure is pointing towards something that humanity has never directly observed before, something large enough to affect the signal as it travels home, something organized enough to produce patterns in data that required AI assistance to decode, something that is not getting simpler as the probe moves deeper into it, something that is, if anything, intensifying. Whatever Voyager 2 has found in the dark between the stars, it has not finished telling us what it is. The probe is still moving, still transmitting. The signals are still coming through. But every watt of power that fades is a sentence cut short. Every instrument that goes dark is a question that may never be answered. And somewhere out there, in a region of interstellar space that was supposed to be uniform and predictable, something is making itself known through the last signals of a machine we sent into the universe 48 years ago, and somehow never expected to hear from again. The signal came back. But the story it is telling is far from over, and the deepest question it leaves behind, the one that will outlast the probe itself, is whether what Voyager 2 is moving through right now is an anomaly, or whether it is the rule, and we simply never had an instrument deep enough to know the difference.